Okay, everybody, so now uh, we will develop the dual LP problem from a mean problem. So this is the weak duality theorem for the mean problem. So the z star must be bigger than or equal to the linear combination of the left hand side, and that must be bigger than or equal to than the linear combination of the right hand side. So this is the theorem. So z star must be bigger than or equal to the LC, the linear combination of the left hand side, and that must be bigger than or equal to the linear combination of the right hand side. Okay, so let's consider this problem. Mean 2x1 plus 3x2 plus 5x3 plus 2x4 plus 3x5, and then subject to x1 plus x2 plus 2x3 plus x4 plus 3x5 bigger than or equal 4, and then 2x1 minus 2x2 plus 3x3 plus x4 plus x5 bigger than or equal 3, and x1, x2, x3, x4, x5 are non-negative. So the first thing that I will do is that I will multiply the first constant with W1, second constant with W2. Okay, so now see that the left hand side, this is the left hand side, is bigger than the right hand side. So for the first constant, it is following the weak duality theorem. See the second constant, the left hand side, it is bigger than or equal to the right hand side. So it is following the weak duality theorem. In order to make this statement not change, so W1 must be positive and W2 must be positive. Okay, now let's do the multiplication. So what we have over here is W1 times 1x1, so W1 plus W2 times 2x1, so that's 2W2, everything times x1, and according to the theorem, see the linear combination of the left hand side must be less than or equal to than the linear combination of the z, so it should be less than or equal to the 2x1. Okay, so since x1 is a positive number, so the sign will not change. So now let's do for the second one, so it should be W1, so this number 2, right, minus 2 x2, oh no, minus 2 W2, and everything multiplied by x2 less than or equal 3. Now for the x3, 2W1 plus 3W2 everything times x3 less than or equal to 5, This is 5x1. This should be 3x2 over here. So for x4, w1 plus w2, everything, times x4 less than or equal to 2x4. This is 5x3, sorry. And then for x5, 3w1 plus w2 times x5 less than or equal to 3x5. Okay, this guy must be this guy must be x4. So since x1 till x5 they are all non-negative, so the sign over here will not change. So I can cancel x1, x2, x3, x4, x5, x5. Okay, sorry, this should be this guy must be x4, sorry. Okay, now the last thing that we will have here is 4w1 plus 3w2, and here the visualization of the weak duality theorem for the mean problem. So we want to make the linear combination of the right hand side very close to the z star. So we want to make it higher. So that means we want to make it bigger. That means we want to maximize it. So this should be sorry, so it should be max over here. Oh, sorry, max. Okay, so what we have over here, it is just another LP, and that LP is max 4w1 plus 3w2 subject to w1 plus 2w2 less than or equal to 2, and then 2w1, no sorry, w1 minus 2w2 less than or equal to 3, and then 2w1 plus 3w2 less than or equal 5, and then w1 plus w2 less than or equal 2, and then 3w1 plus w2 less than or equal 3, and then w1 comma w2, they are both non-negative. So this is the dual, and the original LP problem. This is the primal. And what is the conclusion? So the dual of the mean problem is the max problem, and the dual of the max problem is a mean problem. So the number of dual variable w, so here we have w1 and w2, so we have two w, w1 and w2. So it is the same as the number of constraints that we have. So the number of the dual variable is the same as the number of the constraints in the primal LP. So that's how to get the dual of from a mean linear programming problem. So now let's take a look another example. So the problem that we have is max 5x1 plus 4x2 plus x3 subject to 2x1, 3x2, x3 less than or equal than or equal 5, and then 4x1 plus x2 plus 2x3 bigger than or equal 2, and then 3x1 plus 4x2 plus 2x3 equal 8, and then x1 less than or equal 0, x2 unrestricted, so x3 non-negative. So this is the problem that we have. So it is a max problem, and remember the weak duality theorem for the max problem is z star is less than or equal to the linear combination of the left hand side, and it is less than or equal to the linear combination of the right hand side. Okay, so we will multiply each constant by w1, w2, and w3. See here, the first constant, the left hand side is less than the right hand side, so left hand side is less than the right hand side, so that following the weak duality theorem. So in order to make that not change, so w1 must be positive. Now the second constant, the left hand side is bigger than the right hand side, but according to the weak duality theorem, the left hand side must be less than the right hand side. So in order to make this statement follows the weak duality theorem, so we must change the sign. So in order to change the sign, w2 must be negative. Now see the third constraint, so the left hand side equal the right hand side. According to the weak duality theorem, the left hand side must be equal to must be less than or equal to the right hand side. So the sign here is equal, so it follows the weak duality theorem. So for the sign of w3, it is, I mean, it doesn't matter when you have w3 positive, so the sign will still equal. When you have w3 negative, the sign over here will stay the same. And even when you have w3 equal 0, so the sign will not change, it will stay still it will be equal sign. So it doesn't matter what is the sign of w3 right now, so w3 is unrestricted. Okay, now let's do the multiplication. So what we have over here is, okay, 2w1 plus 4w2 plus 3w3 and everything times x1, and according to the weak duality theorem, it should be less than or equal to 5x1. No, it should be bigger than. Okay, so that's according to the weak duality theorem. But remember, what is the sign of x1 over here? x1 is negative. It is less than or equal 0. So when you multiply an equality with a negative number, so you need to flip the chain. You need to flip the sign. So it is not bigger than or equal to right now, so it should be less than or equal to. Okay, now let's do the second one. So what we have is 3w1 plus w2 plus 4w3 times x2. So according to the theorem, the left hand side must be bigger than or equal to the z. So it should be bigger than or equal to 4x2. But remember, what is the sign of x2 in our original problem? So x2 is unrestricted. So x2 can be a positive number, x2 can be 0, so x2 can be a negative number. So when you make it bigger than or equal to, when x2 is a negative number, so the sign will change. When x2 is a positive number, so it stay like this. Okay, so what is the sign of the this statement over here, such that the weak duality theorem, we still fulfill the weak duality theorem? So what is the sign over here? If x2 is unrestricted, so it should be equal sign, right? Because when x2 is positive, it stays the same. When x2 is negative, it stays the same. When x2 is 0, it stays the same. So when it is equal to, so still it fulfills, or still it follows the weak duality theorem. So that's the second one. And for the third one, okay, what we have is w1 plus 2w2 plus 2w3 everything times x3, and according to the theorem, it should be bigger than or equal to here x3. Okay, so what is the sign of x3? x3 is positive, so when you multiply bigger than or equal to with a positive number, so it stays the same. So we are okay here. So I can cancel x1 here, x2 and x3, so we get 1 over here. And the last thing that we're gonna have is the 5w1 2w2 plus 8w3. So we want to make the linear combination of the right hand side as close as possible to the z star. So we want to minimize this guy. Okay. So what is the dual of the problem? It is mean 5w1 2w2 8w3 subject to 2w1 4w2 3w3 less than or equal 5, 3w1 w2 4w3 equal 4, w1 2w2 2w3 less than or bigger than or equal 1, and w1 is positive, w2 is less than or equal 0, and w3 is unrestricted. Okay, so this is the dual, and this is the primal. I think that is it. Thank you very much.